we add all of our terms. It's called a summation. Now, we did this a little bit, summation, in like probably Algebra 2, when we used this symbol. Have you seen that symbol before? That is the Greek letter sigma, which means summation. That means add them all together. Now, so when we want to find area under a curve, we find all the rectangles, or we find all the cylinders, and we add them together. Summation. And we are moving to page 274. Okay? So this, it says Riemann sum. This guy Riemann said, if I want to find the area, I start and draw it into shapes. I can draw it into rectangles. I can't, if it's a flat surface. My rectangles even don't have to be the same width, if that makes it easier to find the area. So from these Riemann sums, from where we add everything together, we are going to progress to what we call an integral. An integral looks like this sign. That is the integral sign. The first thing we're going to do put all the germs on the outside. Okay. The first thing we're going to do is change from a summation to an integral. That's all we're going to do at first. Then we're going to start evaluating our integrals by finding the area. All right. If I give you, this is what a summation would look like. The limit, let's say as n approaches infinity, of the summation of k equals 1 to n of c sub k squared delta x from 0 to 2. This is a summation. What we're going to do is write it as an integral, just to get used to you writing integrals. Now, what this summation says is that I want to have at least one rectangle up to infinite number. They're not giving you a definite number of rectangles that you're going to draw in this space. At least one up to how many ever. Whatever makes it work best. All right? That's what this means when it says k equals 1 to n and n is infinity. My function is c sub k, meaning it's just giving it a name, squared. This means delta x, as x changes, as I go down the x-axis. And I am looking from 0 to 2. That's what all that says. What we're going to do now is write it as a simple, plain integral.
What's an integral?
Didn't I just show you what an integral was?
Integral?
Integral.
Okay.
That's why I wrote it right there for you.
Okay.
Right there.
Okay. So let's get that.
All right? So, as an integral, this, my smallest number goes on the bottom. my largest number goes on the top. That's a 2. I change my letter to x, and it is squared, and it is a derivative. So I put every integral is a derivative. So that's what the integral looks like.
Where should be 0? Oh,
From here,
okay.
that's a 2. I don't know why it didn't.
Okay, where'd you get the x squared?
Okay, is this c squared?
Yes. Okay.
C sub k is just the name of the term.
Okay. So it's just, and it says k equals 1, so if k equals 2, we do something different. Would it be 2x? You said k equals 1, and then...
We always, no. They all start with k equals 1. You're not ready to go to a different kind yet.
Oh, okay.
All right? So, can we do another one?
Hold on. You said we take the derivative?
No, I said this is how you write it. That's the answer. This is a derivative. What is after the integral is always a derivative. That's why it says dx.
So it's just...
All right, you good with that? So I'm going to give you another one, okay? All right? The limit as n approaches infinity of the summation of k equals 1 to n. This time it is the square root of 4 minus c sub k squared delta x from 0 to 1. All I'm doing is writing it as an integral. That's all. So, my integral, what's the bottom number?
0, 0, 1.
What is my function?
The root 4 minus k squared. X squared. And then...
dx.
Oh. That's it. Oh.
That is it.
Cool.
Does that make sense?
Yeah.
Basically, you're learning to, and by the way, this is called a definite integral because it has a number on bottom and top. Yes.
Okay, so like when you say integral,
Integral.
Is that the little squiggly line?
Yes.
Is that what it looks like on a graph, or is that just this?
That is not on a graph.
Okay, I didn't know if that was just a symbol.
That is not on a graph.
Okay.
Now, what an integral means, if I have, for instance, this one, is that I want to find the area of the graph y equals 5 from -2 to 1. Okay? So I'm going to graph it. Is that what it would look like? Y equals 5 from -2 to 1.
Yes.
That means I start x is -2, end when x is 1. Now I'm going to find the area between that line, or curve, as what it's referred to, and the x-axis. What shape is that? Rectangle? So I believe this is 15.
That one up there? That one up there?
No, this one, sorry.
Oh.
Hold on, could you explain that again?
Explain what?
How did we get
Is that a rectangle? If I draw the line
You drew lines.
Oh.
Yeah.
between the graph and the x-axis, is that a rectangle?
Yes.
Isn't the area length times width?
Yeah.
That's what I did.
Gotcha.
Okay. Okay. That's cool. I like that. Oh no. Let it go.
It is not square units because even though I found the area, what I'm finding is the value of the integral. And the value of the integral is not square units.
Okay.
Now, I don't know if they will get into that very much today, but I will tell you that if it's above the x-axis, it is positive. If it is below the x-axis, it threw you off at the beginning. Are you okay with it now?
All good now.
Okay. So what if I give you an integral? We'll start with a simple one. Negative 2 to 4 of x over 2 plus 3 dx. Okay, to find this value, I'm going to graph it. I'm going to say this is not going to be a rectangle.
Probably.
Okay? So at negative 2, isn't it 2? Huh?
She's really good at this. You would be correct in saying that.
I think it looks like this. What do you think? So, how are you going to find the area of this?
Out ram.
No, you're not, because you're going to find the exact area. And I told you to cut it into pieces and find the area. You want to use a trapezoid.
Oh.
I think a trapezoid is a great idea. Is it a trapezoid?
I think what we should do is cut it off at 2 and go straight across. And do
Well, okay, you do what you want. I'm going to do a trapezoid.
Okay.
Okay. In a trapezoid, I have two parallel sides. Is this them? My parallel sides are the bases. So the area of this is 1/2 h times b1 plus b2. Okay? What is the height? Isn't this the height? What is that? 6. The trapezoid's laying on its side.
Oh.
How tall is this base? 2 plus, how tall is that base? 5. So is it 21? There's no units on integrals. I put X in and found a Y. I just did it in my head.
She just make it smart.
Oh. I'm debating how hard we want to go. there's not really much of a curve yet, because that's coming. What other way? Oh. No, it means it's a derivative. You will care about it later. You don't care about it when we're doing this. So negative 1, 1, right? 0, 2, and 1, 1. Right? Well, it is a pentagon, but it's not what they call a regular pentagon, meaning every side is the same length. So you can't use the pentagon formula. Do you see that I have a rectangle and a triangle?
Yes.
Whatever you have to divide it into, is the rectangle 2?
Yeah.
What is the triangle? Give a difference of 1. So what is the value of this integral? 3. See how we divide that up?
I can do this. Oh, there's a circle on this now.
Those are called theta. How do you graph theta? It is just like x, because on the graph is this pi, and can this be 2 pi?
Sure.
So, when I'm at pi, what would y be? When I plug pi in here, what do I get? Pi? All I'm doing is using theta instead of x. It's just like x.
Really? That's cool.
Okay? So if x is pi, what is y? Pi? When x is 2 pi, what is y?
Right.
So doesn't my shape look like this?
Is that a trapezoid again?
It can be.
Oh, let's do it.
Okay, so it is 1/2. What is the height? Pi times what?
Plus 2 pi.
Is that right?
Oh.
So is this pi over 2 times 3 pi, which is what?
2 pi. 2 pi squared over 2. Oh, okay, I understand now. Got it.
Right? Good with that?